Now let's see how can we understand what to draw conclusions from this confusion matrix. So there are some matrix, and according to the problem statement that we are solving, we will know that which matrix we need to use. So let's see, the first matrix is sensitivity, often called as recall. Now what is sensitivity? It means what percentage of occurrences with actually true values were predicted true or correctly identified. Which means out of the actually true cases, in the ground truth, the number of cases that were true, how many of them were actually predicted as true. So it's TP by TP plus Fn. True positive divided by actual number of actual number of ground truth has 1. This is called as sensitivity or recall. An example can be the churn system, or the system in which we are predicting which customers will stay and which will not stay. So there, if the customer actually stayed, it means it means the actual is 1, and if we predicted that it will stay is 1. So false negative in that case will be where we had predicted that it will not stay. The customer will not stay, but the customer actually stayed. So that is a case of false negative. Predicted false, like predicted and actuals are not matching, thus false, and we had predicted negative in that case. So such cases or the false negatives are very costly in case of recall. It's like we are missing the user, or we are missing the customer that would have stayed. We missed to predict as true. Similarly, the second matrix is called specificity. Here, what percentage of occurrence with actually false values were predicted as false or predicted correctly. So here we will see actually false, actually in the ground truth that were 0, or the customers that were not that did not stay in the system. Amongst them, how many the machine or the model had actually predicted that it will not stay. So it is true negative. So specificity becomes true negative divided by true negative plus false positives. Now here false positive, that is the customer had not stayed, but we or the model had predicted true. Such cases are false positives here, and such cases can be costly. Such false positives are costly because what if there is a customer whom I had given a notification about my product, but the customer did not stay anyway. So the cost of that notification is the extra overhead for the company. Now next matrix is accuracy. Accuracy means overall correctness. It is very useful in case the data set is balanced, that is number of zeros or number of negative cases and number of positive cases in the actual ground truth report are the same. In such cases we can check for accuracy, else accuracy can have very biased meaning. Let's see the formula for accuracy first. So accuracy means how many in what all cases the machine or the model actually predicted correctly. So there will be 0 0 and 1 1, that is true negative and true positive, divided by total number of cases or total number of rows. Now accuracy can be misleading because suppose there are 99 negative cases and 1 positive case, and my model always says negative, so it says 100 times as 0. In this case the accuracy will come out to be 99%, but we know that the model is only saying one value, it is not saying both of the values. So suppose in my test data set there are only 2 negative cases and 98 positive cases. Then in this case my model will always say no and my accuracy will fall to 2%. So accuracy is not a correct measure where the actual data set is not balanced. Next we have precision. Now precision says what percentage of the predicted positive, not all occurrences, what percentage of the predicted positives, how many are correct, like how many are true positives. Whatever the model is predicting, means in the row wise, whatever the model is predicting, false positive or true positive, whatever the model is predicting as positive, out of them how many are accurate or correctly identified, that is the true positives. So it is true positive by true positive plus false negative. Now an example can be the healthcare sector where we have cancer detection. Now out of whatever the number of patients that the model is predicting as true, that is they have cancer, how many of the predicted patients actually have the cancer, that is true positive. Now here false positive, if we increase false positive, or if the model says that the patient has cancer but the patient actually has no cancer, then it is not good user experience and thus it should be avoided. So here false positives can be costly. So that is another metric called precision, mostly used in healthcare sectors. And one more matrix is called F1 score. F1 is the harmonic mean of precision and recall. So in the cases where both precision and recall both matter, there we check F1 score.